Hey guys, it's Mr. Wynn, and we're going to talk about factoring polynomials, but special cases. So we've learned how to factor by grouping last time, and now I'm going to show you how, without doing all that, you can write your answer if it looks and is set up a certain way, right? And let's see. That means our essential question is just going to be, how do I factor special cases? Okay, you have really three different scenarios, okay? Difference of squares, sum of cubes, and difference of cubes. There's a line here to show you that there's only one type where it's a square. So if you see an exponent of a 2 here, that 2 is squared, right? You can only use difference of squares, all right? If it's a cubed, like the examples below right here, those cube roots, right? A cube here and a cube there and here, right? You would either use the sum of cubes or the difference in cubes. An easy way to tell is if you're adding sum of cubes, difference subtracting, right? Difference of cubes. Okay? So first off, let's look at difference of squares. You'll notice that if you square A and you square B and you subtract them, you can easily write them as A minus B and then A plus B. Right? So you have two terms, A and B, and if they're being subtracted, you can just write A minus B, parentheses, another A plus B. And the second you realize it, you can go ahead and just write that as your answer. That's the special case. Right? So in this case, if I look at this, here's A, x squared, right? And here's B, 16. Right? If those are squares, right? That means A squared is going to be x squared. And that also means B squared is going to be 16, right? It's in the corresponding spots, right? A, B squared, right? So in that case, let me erase these. If I can square root this to find out what A is, right? If I can square root them to find out what A is, that would give me square cancels, square root cancels square. Square root here cancels that square as well. That means A is just, let me rewrite that, A is just x. Right? Do the same with B. If I can square B squared and the B squared in the problem, right? That means B is just going to be, B squares cancel, square root of 16 is just going to be 4. And that way I can write it as, your A, x, minus your B, right? And then A again, but this time plus your B, all right? A minus B, A plus B, x minus 4, x plus 4. And that's your answer. You don't have to do any of the math, and just by looking at it, you can go ahead and write that, okay? The thing you do got to know is you got to know your perfect squares. So you got to know, just recognize the numbers. 1 squared would be 1, 2 squared would be 4, 3 squared would be 9, 4 squared, 16. These are just numbers you should recognize, and maybe if you see these numbers, you'll be able to tell me. You'll be able to say that it's a perfect square, it's a special case, and you can just go ahead and write the answer. You don't have to do the math out. 8 squared is 64. 9 times 9 is 81. And of course, 10 times 10 is 100. Right? Those are just numbers. These are just numbers that you should recognize. If you see those numbers, it may be a special case where I can just write the answer. Right? So notice here, as your A, you've got 4x squared. The 4 tells me here, right, I've got a special case. But also the 25, I also have a perfect square here. 2 perfect squares, that means I can grab the square root and just write the square, answer, okay? So that means, again, to find out A squared is 4x squared. If I grab the square root of both, I'll know what A is and can just write my answer. So squares cancel square. Square root of just the 4 part is going to give you 2. Square root of the x squared cancels the square, just 2x. Same thing with the B. If I grab the square root of the second term here, I will know I can grab the B and just write it as my answer. Square root of 25 is 5. That means as your answer, A, 2x, minus your B, which is 5, times A, which is 2x, plus your B, which is 5. That's your answer. All right, just one of those things you will automatically recognize, and you really don't have to write all this out, and you should recognize it and just go ahead and write 2x minus 5 times 2x plus 5. All right, what about cubes? Cube roots, same thing. You got to know your cube roots, but I don't expect you to know that many, okay? Let's just go to 5. Like 1 squared, we know 1 times 1 is 1, times another 1 is 1. 2 times 2 is, oops, this is cube roots. 2 times 2 is 4. 4 times another 2, 8. 3 times 3 is 9. 3 times another 3, 27. 4 times 4 is 16. 16 times another 4, 64. And lastly, 5 times 5 is 25. 5 times another 25, 125. Right? Those are the ones. Like from there on out, they get a little weird. You don't have to memorize those. But these numbers, at least, you should recognize they may be cube roots. They're perfect cubes. So here, I have x cubed plus 125. So that means your a is your first term. Okay? A cubed is equal to x cubed. B cubed would be equal to 125. Now the thing is, look back at your prompt. All right, look back at your answer. Sum of cube or difference of cube. We know we're adding here, right? We're adding, so that means we're taking the sum of cubes. The setup is a little different. If you're adding cubes, that means you do a plus b, but then in your second parentheses, it's not just a minus b, but it's going to be a squared minus a times b plus b squared. Notice how it's plus and then minus. But with difference of cubes, you do, when you subtract, you do a minus in the first one, a plus in the other one. Those are the real difference, but it's always, a squares, ab, b squared, okay? Always a squared, ab, b squared. So if I go back to this problem, I'm going to clear this out so we can kind of see it. All right, a cubed, if I cube root this, that means I get the cube root of this, okay? The cube roots cancels exponent of 3, so a is just going to be x. If I cube root this, the b cubed, cube root of 125 is what I know. It's going to be 5, so b is equal to 5. So let's fill out our answer, right? So it's going to be your a, and we know we're doing the sum, so it's a plus b, which is just going to be x plus your b, which is 5. And then we take a squared, so square the x, so it's just going to be x squared, minus this time, remember plus and then minus, a times b, right? I'm right here, a plus b, or a times b, which is just x times 5. We're kind of multiplying these two, which x times 5 is just going to give us 5x. And then we take the b squared, so 5 times 5, 25, which is going to be plus 25. And that's your answer. Okay? Do the same over here. This time it's a difference, so I'll be using this second equation here, right, or the last one in the formula. So I know a perfect square of 27 is your a. 27's in my, my answer. 8 is also there, right? That's good. Let's color code this. 8 is also there. And I know I have the exponents there. Exponents of 3. That's good. So everything's good. They are perfect cubes. That means I can just write my answer, right? I can use the formula. So 27, a is going to be, right, a cubed is going to be 27x cubed. And if I grab the cube root of each, I can figure out what a is. A is going to be, cube root of 27 is 3. X, take away that cube root, it's just going to be 3x. B, same thing. B cubed is going to be 8y cubed. But if I cube root each, I can grab b by itself, which would give me b equals cube root of 8 is 2. Cube root cancels the cube. It's going to be y. So it'll be 2y. And plug it into your equation. Now this is the difference. So I have parentheses 3x, your a, minus your b, which is 2y. And then we're going to take a squared. So it's like we're doing 3x squared. Let's just do that to the side. We're doing a squared. is 3x, but squared. That gives us 3 squared is 3 times 3 is 9. X to the square root to the x, 9x squared. 9x squared. And then a times b, so we're going to multiply 3x and 2y. That's going to be 3 times 2 is 6. X times y is just x, y. So plus 6xy. And then it's going to be b squared. So b squared. B squared is going to be 2y. Square of that. So square 2 times 2, 4. Put the 2 on the y. 4y squared plus 4y squared. That's your answer. Okay. Looks like a lot, but really we're just following the formula and making sure it's still clean, simplifying down. Okay? And that's it. Thank you.